This video will include the Unit 9 review questions to help you study and prepare for Test 3. Prior to starting these problems, be sure that your calculator is in the correct mode. Under the Mode key, you want to make sure that you are in degrees. It does matter when you are working with these trig ratios and law of sines, law of cosines. Let's go ahead and start with problem number 1. For the triangle, write the sine, cosine, and tangent ratio and its inverse for the theta angle. So we're going to let angle E be the theta. So here at angle E, that is our theta. So let's go ahead and label opposite, adjacent, and of course hypotenuse is across from the 90 degree. So from our theta angle, we label our triangle opposite, adjacent, and hypotenuse based on where your given angle is at. So we're going to write each of our ratios. So let's start with the first one. Sine of our angle, so 53, equals, sine is opposite, so we'll do 8 over hypotenuse, so 10. Remember your saying to help you remember that. Some old hippie, so sine, opposite, hypotenuse. Then for cosine, so from our theta angle, for cosine, so cosine of 53, we're going to want adjacent, so that is 6 over hypotenuse, that is 10. So for cosine, remember, caught another hippie. Cosine is adjacent and hypotenuse. And then for tangent, so tangent of 53, from our theta angle, tangent is going to be opposite, so 8 over adjacent will give us 6. So tripping on algebra. So our theta angle, opposite is 8, adjacent is the 6. Then to do the inverse, we would say our angle, so angle 53, and really you wouldn't need the angle symbol if you wouldn't want, so just 53 degrees equals inverse sine, and you use the same ratio, 8 over 10. It is still going to be opposite over hypotenuse. 53 degrees equals inverse cosine of, again, our same ratio for cosine, adjacent over hypotenuse. And then finally, 53 degrees equals inverse tangent of our ratio, 8 over 6, which is opposite over adjacent. The good thing about setting those problems up is you could test and try some of them in the calculator. So let's just type in sine, of course make sure it's on and in the correct mode, sine of 53. That gives us whatever this crazy decimal is. Let's also make sure 8 out of 10. Notice, due to rounding, they are pretty close. So I would assume that these values in our triangle that was originally given were probably rounded in order to make that image. But if you notice, if you round this to the nearest tenths, it would round to 0.8. Okay. Let's check another one. Maybe let's do the tangent. So tangent of 53, whatever that crazy decimal is, and then divide out your fraction. 8 out of 6. And notice, again, very, very close. If you just round in the nearest tenth, you would never know that they were any different. You can even test or check with the inverse ratios. Let's go ahead and do inverse cosine. We say that that's 6 over 10. And there's where the rounding comes in place. Our angle is actually 53 point more. And because we've rounded, of course, that's where these ratios are a little bit off when we check them. But because of rounding, we're confident that it is close enough. So now that we've practiced and set up some ratios, let's actually use them to solve. Let's look at question number 5. A support wire is attached to the top of an antenna. The support wire connects to the ground 15 feet from the bottom of the antenna. The support wire and the ground meet at an angle with measure 70 degrees as shown. To the nearest foot, what is the height of the antenna? So our diagram here shows everything that the problem explained there. Because we're trying to find the height of this antenna and it forms a right triangle, we're going to use our right triangle trig of sine, cosine, or tangent. So that 70 degrees is going to be our theta angle. And let's label the side we need to find. So that one's going to be opposite. And the side that we're given, that's going to be adjacent. You could label your hypotenuse, however, you don't know that value and you don't need to know that value. So let's only label the things we know or need to know to help us find our ratio. So think about your ratio. Some old hippie, I would need the hypotenuse. So we're not going to use sine. Caught another hippie, so again, another hippie, I would need the hypotenuse, so we're not going to use cosine. Tripping on algebra, so tangent of our angle, opposite and adjacent will help us solve for our missing side. So tangent of theta is opposite over adjacent. This is what we will use to help solve for the missing side length here. So tangent of 70, put your theta angle in that place. Opposite, we don't know, so use a variable. I'm just going to use X. You can use A for antenna. You can use any variable. And then our adjacent side is 15. Once you have your trig ratio set up, of course you had to have found the correct trig ratio, sine, cosine, or tangent, and you have to set it up correctly. We now just solve. So maybe take a moment to check, did you pick the right ratio? Opposite and adjacent, it does make sense that we pick tangent, and then we set it up according to that ratio, opposite and then adjacent. So in order to solve, you're going to multiply by whatever is in the denominator, because that's what they're dividing by. So we're going to multiply both sides by 15. Notice once I do that, it does get x by itself. So once you have your variable by itself, you can go and type this in the calculator. So 15 tangent of 70, that gives us, and it told us to round to the nearest foot, so that'd be the whole number. That'd give us 41 feet. So that is how tall that antenna would be. And always stop and make sure, does that make sense? If the support wire is 15 feet away, our angle of 70 degrees, it does make sense to have an antenna of 41 feet. If you get something that's like 12 foot tall, that would not make sense that it is much shorter than how far away the support wire is. So always think about, does my answer make sense, especially when it's given to you as a real world problem. Let's take a look at our next example, next problem here, number 6. We know that the sum of angle V and angle W is 90 degrees, meaning these are complementary angles if the sum is 90 degrees. So if cosine of W is 5 over 13, what is sine of V? If we know cosine of this angle, W, it's wanting to know the sine of V. Well, that is just something that is good to know, that the sine of one angle equals the cosine of the other. So we will pick the same answer of 5 over 13. To help make sense of this, let's actually draw a triangle. So it's a right triangle, because if the other two angles add to be 90 degrees, we would have to have 90 degrees left over. So let's let one of them be V and one of them be W. It gave us cosine of W. So if we're standing here at W, cosine is adjacent, so the 5 would be the adjacent. Standing there at W, 5 is adjacent, and then 13 would be the hypotenuse. Because the ratio for cosine is adjacent hypotenuse. Well, now we're actually asked for our problem, what is sine of V? So let's let this be our theta angle, and let's find sine. So sine is opposite over hypotenuse. So you'll use those same two values, and that's why we pick the same fraction. The sine of one angle equals the cosine of the other. Question number 8. We're going to find the measure of the indicated side or angle. We're going to round our side lengths to the nearest tenth and our angle measures to the nearest whole degree. So let's take a look. We want to find the side AB. So it's already labeled here as an X. We have our angle here. We'll let that be our theta. And we have the measure of 6. So again, let's only label the sides we need to know and that we already know. So I'm going to label this adjacent side. And I'm going to label this hypotenuse. We are not going to worry about labeling the opposite side because we don't need to know that, and I don't have any information about that side. So once we have our sides labeled, adjacent and hypotenuse will help you know what trig ratio to select in order to solve. Adjacent hypotenuse is the cosine ratio. So cosine of theta is adjacent over hypotenuse. So that's how we will set up our problem. Cosine of our angle, so 73, equals adjacent is x over hypotenuse is 6. So now that we have our ratio set up, we're now ready to solve. We're going to multiply by whatever they have divided. In order to cancel those out, you have to multiply on both sides because we want to keep it equal. But those will cancel, leaving our variable by itself. So we're ready now to go to our calculator and type that in. 6 cosine of 73. If we are rounding a side length, it says to the nearest tenth. So the nearest tenth behind that would make that round up. So 1.8. So x equals 1.8, or you could say even AB equals 1.8. Let's take a look at question number 9. Again, let's label your triangle, our theta angle, and label the sides that are given or you need to find. So we have opposite and adjacent. If we're trying to find QR, that is our adjacent side. We were given the opposite side. Opposite and adjacent is the tangent ratio. So set up your equation using the tangent ratio. So tangent of theta, so put your 49 degrees. Opposite is the 14. Adjacent is the piece that we're trying to find. Notice here we are not going to just multiply by 14. They're not dividing by 14. Make sure you multiply by what is being divided. So we're going to multiply both sides by x. So x tangent of 49 is what we have on the left side equals, those x's do cancel each other out, so we're equaling 14. Notice, however, our variable's not by itself. We'll need to divide both sides by tangent of 49. That gets our variable x by itself. So we'll take, and that's when we'll type in the calculator, 14 divided by tangent of 49, or you could have even done alpha y equals to do the fraction. Rounding again to the side length to the nearest tenths, so behind that is a 7, it would make it round up to 12.2. Let's look now at question number 10. This time we're solving for an angle. So our angle we want to solve for here is angle x. We have the opposite side and we have the hypotenuse. Opposite and hypotenuse is going to be sine because we're wanting to find an angle. So angle theta, we will actually use inverse sine and set up our ratio. So angle x is what we're solving for, so you could leave it angle theta or just label it as what you're trying to solve. So angle x is going to equal inverse sine. Opposite side is 40. The hypotenuse is 42. And once our variable's by itself, we're ready to type it in our calculator. That's the cool thing about finding the angle with these trig ratios is once you get it set up, you're ready to go straight to the calculator. So inverse sine, remember that second sine, and type in 40 divided by 42. And again, you could have used alpha y equals. When we are solving for an angle, it's asked for the nearest whole degree. So that 2 does not make this round up. So angle X is going to be 72 degrees. Now for question number 11. Again, solving for an angle. So a theta is there at angle J. Label your triangle. We have the adjacent side and the hypotenuse. The ratio for adjacent hypotenuse is cosine, and because we are solving for an angle, we're going to use inverse cosine. So that's adjacent over hypotenuse. So angle theta equals, and actually let's put in angle J. Angle J equals inverse cosine. The ratio is adjacent, so we'll do our 24 over our hypotenuse, which is 36. Once our variable is by itself, and that's the good thing about these inverse ratios, they are already ready to type in the calculator. So once your variable is by itself, type it in. So second cosine, 24 out of 36. So angle J is going to equal, rounding nearest whole degree, is 48 degrees. So anytime we saw a right triangle, we can use sine, cosine, or tangent by labeling our triangle with our opposite adjacent hypotenuse, and then pick the correct ratio and set that up. We also learned with other triangles, you can use law of sines and law of cosines to solve. So let's look at this triangle. We have the angle and the side opposite, angle, and we're trying to find the side opposite. So just like the trig ratio sine, sine is opposite. This will be law of sines because we have angle and opposite angle, and we're trying to find the opposite. So the law of sine is sine of our angle over the side, sine of our angle over the side. So let's set that up. I like to go with the pair that I know. So sine of 97, being careful to put your angle measure in there with the word sine. With our 12 is the opposite side. And then again here, sine of the angle measure, so the 42, opposite with our side. Once you have it set up, we cross multiply. So we have d sine of 97 equals 12 sine of 42. We do not want to type anything in the calculator until we get our variable by itself. So let's divide by sine of 92. Let's divide by sine of 97. Sine of 97, and that will give us our variable. So d equals, and be very careful how you type this in. There's a couple different options. You can tell the calculator that you want to multiply the numerator, go ahead and press enter, and then divide by sine of 97, or just set it up as a fraction. So alpha y equals, do 12 sine of 42, and then sine of 97. So rounding to the nearest again here, because it's a side length, we're going to do the nearest tenths. That 8 does make it round up, so 8.1. Be very careful when you solve on how you type it in the calculator. It does matter. If you type all this in at one line, and just do divide by 97, sine of 97, the calculator thinks you're still wanting to divide just the sine of 42. So be very careful how you set that up and type it in correctly to your calculator. Let's look at this next problem. So notice here we have our angle and the two sides that are adjacent. So cosine, with our trig ratios, cosine was the adjacent. So if you have the angle and the two sides that are adjacent, you're going to use law of cosines. So in order to solve with law of cosines, remember it starts like Pythagorean theorem. So a squared plus b squared equals c squared, and then it was minus 2ab cosine of c. So cosine, law of cosines, your C angle is what you're going to be taking the cosine of. So our angle is going to be the 80, and then everything else falls in place after that. The A and B, the 8 and 6 really don't matter which one you call A or B. And the side I'm solving for will be opposite of your angle. So let's set it up. Q squared equals, I'm going to go ahead and plug in 8 squared plus 6 squared minus, again, do your 2 times, do your A and B. They're not squared here, so just 8 and 6 cosine of that angle. It must be the angle that has the adjacent sides because it's law of cosine and cosine is adjacent. That must be the angle with the adjacent sides that you used for A and B. So we're going to type all of this in the calculator, and that will give us Q squared. Be very careful. We're not just asking for Q squared. We want to know the value of Q. That will give us this side length. So make sure you take the final step of solving for Q. All right, let's first set up this part here. 8 squared plus 6 squared. Try that again. 8 squared plus 6 squared minus 2 times 8 times 6. And we're going to do cosine of our 80. Because you're typing in so much, be very careful that you type it in correctly, or just type it in a second time to make sure you get that same value. I'm going to go ahead and round that 83.3, and then we'll end up taking the square root to get 9.1. When you take the square root to get Q, 9.1. So do not stop with just the Q squared or whatever variable you have squared. We want to get it by itself by taking the square root and give the value of that side length. Of course, you could finish all of Unit 9 to help you review for Test 3.